Okay, so when I look at this question, I'm going to break down the information. I'm going to say, it's okay, well, there is a conical. They kind of told me what kind of shapes is that. Even vertex is down. Those are the things that help me to draw. And 10 foot across the top and 12 feet deep. Those are the information that I'm going to draw. Water is flowing into the tank. So water is flowing, is not leaking out. So remember, if it's leaking out, my dV/dt is negative. Does that make sense? But it's flow into, so that's just as important. So those are the key information flow into. The tank at a rate 10 cubic feet. Remember, cubic feet. What does that mean? Right? So that means something else. Find the rate of changing of depth. Depth. This is the things I'm looking at, the depth of the water when the water is 8 feet tall, 8 feet deep. So this is the condition. So those are the things that I would say. So this is a condition right here. Condition is 8. Am I going too fast? Did you guys draw a picture?
Yeah.
It should have like something like this. Okay, so I'm gonna draw another line from here to here. Okay, I'm not gonna be professional, it's a small gap. Okay. Just don't pay attention to the bottom. Okay. I can't fix everything. So flowing water is flowing in, right? There's water that's going in, right? So obviously there's things like that. But they're 10 foot across the top, so 10 is all the way from the top. So this is 10 feet. And 12 feet from the top to bottom. So that's 12 feet. Right? So then you say, okay, well, that's great. We got this. We got this. And so I'm going to draw it another line here. So it turns out there's a two relationship here. And there was a reason being that you had to deal with two relationship in this situation. So let's look at the question. What is giving? Anybody tell me what is giving? Diameter is 10. But what else? Like, what is giving in this one? This is the condition also. But what is giving? Like, actually giving. Like, far as in terms of rate.
Change of volume over time is 10 feet per minute.
dV/dt? Okay. dV/dt is equal to what? 10 cubic feet, so feet to the dirt per what? Per minute? Okay. That's understandable. And what are you looking for? What's the rate of change of depth? dH/dt. Right? When h is equal to 8. So those are the things that this thing. Now, there is something that's constant in this case. What is a constant? What is things that doesn't change in this case? The comb, right? The diameter and the depth, that's not going to changing. So there's no changing on that. But we want a dH/dt when h is equal to 8. But let's figure out the first relationship. So this question, you need a two relationship. In the first relationship is going to be 1/3 pi r squared h. Does that make sense? But if I were to do derivative with respect to time, what kind of problem you will foresee here? If I do derivative with respect to time here, I have two. I have two things that I have issue because there was not only that, there was a product rule too. There was between r squared h. That's going to be a product rule, and dH/dt and dV/dt. They both the dH/dt and dR/dt. And I have dV/dt, and it's like there's a lot of variables. So there's got to be a second relationship that's going to help you figure out how do we reduce that variable down to 1. So that's using the constant here. The constant is going to be what? Well, constant here, there's I'm going to use I'm gonna use a 5 for radius because I think I see a similar triangle. Do you guys see a similar triangle? I see a similar triangle. So, come on, man. Damn you, Logan. Stop curse me. Whatever, that's close enough. So there was water, right? It's blue, right? So there was, obviously there's water, but the comb never changed, right? The comb is gonna be that there's similar relationship between the radius and the height. So let's just say if I have r over h is equal to 5 over 12. Does that make sense? This is the second relationship. Does that make sense? Because that's a similar triangle back in geometry. Can I figure out what is the 5h equal to 12r using cross multiply? And what do I want to solve? Do I want to solve for r or h in this case?
What was the problem asking for?
Well, the problem is asking dh dt.
I want to solve for 8. Yeah. You want to solve for 12 because we have h right here. Wouldn't you want to solve for r so you can plug in r into any other equation that you have?
So r or h? Make up your mind.
R so you can plug in r into b, right?
Who voted for h? Everybody changed? Earlier I hear a lot of h. Somebody changed it. Somebody switched team. Those backstabbers. So I will solve for r. Yeah, r is good. So r is equal to 5h over 12. Am I going too fast? Now what happened? I can replace that r, right? And it becomes one variable. This second relationship is help you reduce a variable. So help reduce variables. So variable. Why? Because you have too many variables there. I don't want to deal with that. So volume is equal to 1/3 pi r squared. Well, r is no longer r, so it's going to be 5h over 12 times square times h. Does that make sense? So v equal to 1/3 pi. And this one is going to be 25 h squared over 144. Am I doing okay? Does that make sense or no?
What happened to the last h?
Oh, yep, you're right. H. And so can I just 25 over 144 times 3? Anybody know what that? I have no idea. What is it, Nisha? 432. Thank you. Pi and then h to the third, right? So can I take a derivative? And 25 432 times 3. Hopefully that can cancel. 7 9. Yeah, that can cancel. H squared dh dt.
And pi.
And pi. Good. Okay, so what is the h in this case? 8. So is equal to 25 times 432 times 3 times 64 times dh dt and times pi. And what is dh dt? Do they dh dt is unknown. And what is dv dt? 10. So I can figure out 10 is. 64 times anything is 432. Is that 64 times 5 is 320.
When you get rid of 3, it just goes back to 144.
Okay, that's a good idea. That's 144. and 64 and 144. I would say 16, or maybe more. 32? No, 32. No, 16. Right. This is a 4. This is a 9. Am I okay? Yeah, so it'd be 90 if I multiply 9 on both sides over 100 is equal to, and then pi is on bottom. Pi is divided by pi, so pi is on the bottom, right? So it'd be dh dt. So it'd be 9 over 10 pi.
It's 10 feet per second. The derivative, the volume is with respect to time is 10 per second.
Yeah. So we're gonna take care of the unit now. DHET. So this one should be feet per what? Per second or per minute? I think it's per minute. So this one is a longer one that where you had to deal with a longer situation. AP exam not gonna test this part anymore. It's just because a lot of students that will have hard time with a second relationship. But I still like to introduce it to you. I don't want it to just show you says. I think when we teach calculus, we're gonna make sure to teach you right. But although it's not gonna be tested. I will test you though, because I will expect you to know this. Any question about this? So homework today, you're gonna figure out a way to break down those informations, and to deal with those situation in details and how you get from one side to the other side. This is okay? Okay. So again, only time that you have to deal with two relationship, I think, it's only with the cone. That's the only time you had to deal with that. So most of the time you don't have to deal with it. Okay, I don't have time to give you a practice problem. I really want you to practice at home. So I want to go through as many example questions as possible. Hopefully that this is very detailed. Is this detailed? Okay, it's okay? Okay. But you are at home are going to have some home question you're going to have to figure out. So if you go back and look at things. Now let's talk about moving ladder problem. So moving ladder is a famous, it's a AP exam common questions now. Now this is a question that will show up on either my test or on anybody else's test. Cone is not going to show up, and there's a shadow problem is not going to show up as well. But we're going to talk about shadow as well. So let's just say if I have we're going to take a picture of another question, which is question 21. And this one has 3 parts because they can extensive to all 3 parts. And this one is very detailed because it actually talk about product rules and everything in terms of related rates. So we have 8 questions right here. And sorry, let me import it here. Camera like this. How many of you guys remember this problem? You do? Good, good. Do you remember doing the C? It says find the rate of angle between the ladder and the wall is changing when the base of the ladder is 7 feet away. Yeah. Also did that with Mr. Craig's class? Okay, all right. Good. If you know how to do it, you want to start? Or you want me to go over it? Let's start drawing a picture. Let's start identify things. Let's start give out things. So those A, B, C in this part, and I think each this part is actually a good lesson. So it's actually 3 different separate parts here, and you had to focus on each small parts. And each question is a different way to deal with something. And this is what a question we start with last time. It seems like nobody have issue, which is if I have a ladder sliding down the wall. Which is normally, I don't think ladder does slide down. Oh, you can pull away, so the guy's pulling away from the base. But you don't pull away the ladder that way. So when they talk about word problem, they need to make it more logical.
I mean, a ladder could slide down.
Huh?
A ladder could slide
No, this is too much friction for them to slide.
If it's like a dysfunctional one.
Huh?
If it's dysfunctional, like it has safety inspection.
Yeah. Or if it's not processed correctly, it can just slide down the wall.
Yeah, but you don't move the ladder by pulling the base, right?
Someone had
Well, no.
You're gonna break the ladder if you do that. So I don't know. It's not very logical. But the second picture is actually shows better. The second picture is you pulling a plank upwards. Then that can make sense. You probably use a machine. You don't use a human being to pull that thing. So that doesn't make sense as far as how that picture goes. But yeah. I like part B and I like part C. Part C is tended to be the most common one now recently. On a recent exam, they ask angle changing more than anything else. So, so I will make sure I know the ladder for sure. The ladder is always a problem that's gonna show. So I should go over it. Okay, let's draw. Those pictures are already there. So this thing is pulling away. So we talk about also on here. The one thing I forgot to mention is this: identify what is giving and what is asking. At the same time, you might need to assign variables. So assign variables because at this case there's no variable, so you have to assign variables. So in this case, the picture is like this, but there is no variable involved. So I will assign variable to talk about how to deal with this problem. So let's just draw a picture again, right? Wall supposed to be 90 degree. A ladder is gonna be like this. And you don't need to draw a perfect picture because in the past I have people trying to draw a perfect picture on the test. You spend 20 minutes on the picture, then that's bad. So this thing is pulling away, so it's 2 feet per second. So it's pulling away 2 feet per second. So obviously this is also going down too. And we talk about they don't go exactly same speed. If I pull away 2 feet per second, it does not go down 2 feet per second because it really depends on the angle. Does that make sense? Intuitively, it probably, like the first time you never did this problem, you probably feel like you're pulling away 2 feet, it should go down 2 feet. But idea is you're pulling more away, right? It should go down when it's lower, it's gonna go down faster because you only need to pull a small inch to move a lot. So it will increase the speed actually. It was like this, it will increase the speed as though you're pulling away. Although the bottom is pulling exactly the same speed. Does that make sense? The bottom I can pull away same speed, but the ladder is actually increased speed is going down. But also pay attention what is negative and what is positive because that usually gonna give you a good hint. If you have no idea how to do a problem, at least you can pick the right sign one, right? If it's going down, my x, it should be negative, right? Your dx dt should be positive. So we assume that this side is x and this side is y. So dy dt should be negative, dx dt should be positive. So if they ask you something like a multiple choice, guess what? You can process elimination. If you got a dy dt is a positive, that doesn't make sense. And those are the things that you should pay attention to. Now, what else? They want to know is how fast is the top of the letter moving down. So it's dy dt when what? When the x is equal to what? 7 or 15 or 24. I'm just going to do 7. I don't want to do 15 and 24. By the way, this is a Pythagorean triplets. Most of you guys don't know for SAT. Pythagorean triplet, there are 3. The most common one is 3, 4, 5 Pythagorean triplets. Do you guys know this? That's Pythagorean triplet. The second popular one is 5, 12, 13, which has happened on the earlier question. It's 5, 12, 13. The last one is 7, 24, 25. And it can be any multiple of this. So 3, 4, 5 could be 6, 8, 10, could be 15, 20, 25. They all can be multiple of this. So on SAT, most common one is going to be 3, 4, 5 triangle. If you see a right triangle, you see a 5 on the hypotenuse, you see a 4, then the other side must be 3. Or it could be ratio of that. Okay, those are the good SAT hints. 5, 12, 13 is common one. 5, 12, 25 is the common one. This one. So the reason why I mentioned 7, 24, 25, I didn't want to do the work. I hear what will be the relationship here. Anyone?
You can use the Pythagorean theorem.
Yay! My good old favorite Pythagorean, right? Now, this is the constant I'm talking about. The ladder does not change. Why that's going to be helpful? Because when you take a derivative with respect to time, what will happen?
What did 25 be squared?
25 squared, yeah. 2x dx dt, right? Plus 2y dy dt. Does that make sense? And that's equal to 0. Because the length is not changing. It's always 25. It does not change. So this is going to be something that's going to help you a lot. Okay? We have questions here? Now, do we have the x? We have the 7, right?
Yeah.
Do we have dx dt? 2, right? Plus 2, do we have y? No.
We do,
Well,
we
we
do
do now.
because 7, 24, 25, so 24.
So it'll be 24, right? And this 24, I get it from Pythagorean identity. So if I really want it, I can do 7 squared plus y squared is equal to 25 squared. And that's going to be y squared equal to 625 minus 49. And y squared is 576. Y is equal to 24 plus minus, but in this case it's plus. So at this 1428 is equal to negative 48 dy dt. So dy dt is going to be 28 over minus 48, which is negative 7 over 12. Thank you. Did anybody remember this?
Yeah.
Start coming back? Okay. How about the second one? The second question is actually very interesting. Normally AP exam doesn't ask like a question like a B. Huh? They say triangle form on the side of the house. The ladder and the ground, the rate at which area the triangle is changing when base of the ladder is 7 feet. So we already work out 7 feet. So we don't work on 15 feet and 24 feet because I don't have time. But we already work out 7 feet, which is good. Okay, base is 7 feet. So how would I do this question? What would be the relationship I want to do in this case for us for B? Area triangle. So what would be area triangle in this case? Okay, so 1/2. But the base right here, we don't call the base. X times y. Is there any way I can reduce the variables? Probably not gonna help you, right? There was a Pythagorean, that's just not gonna be pretty because you're gonna get square root. So that's actually gonna make it worse. So what's the only way to do this? Yep. So dA dt. But it's not that bad because 1/2, the product rule is gonna be dx dt, or dx dt times y plus x dy dt. But we have all the information. Dx dt is 2, y is 24, I think, plus x is what? 7. And dy dt, we got it from previous one right here. Do you see that? So let me draw some arrow. Dy dt is negative 7 over 12 because that's what happened at 7 feet. So that does have work it out. I don't want to work out the math. You guys can figure out the math part. I'm not smart enough to work out the math. Minus 49 over 12. And then, yeah, solve for that. I'm not worried about that part. C, my favorite one. Find the rate of change when angle between the ladder of the wall of the house is changing when the base of the ladder is 7 feet to the wall. Any idea how to start?
Can you say it again, please?
It says find the rate at which the angle between the ladder and the wall, which is the top part, of the house is changing when the base of ladder is 7 feet away from the wall. Yep.
Can you maybe use cosine since you're using the base as x over the ladder, which is
Okay, let's assume that we're going to use cosine for now. Okay. And I don't think I will use cosine, but let's assume that we use cosine. Okay. I will probably use the other one. But what is giving though? Dx dt is giving, right? Dx dt is giving. And you say using cosine. Well, you start with the right thing. You have to use SOHCAHTOA here. Anytime you have angles changing, SOHCAHTOA for sure. Now, I will tell student, this is what I prefer. I'm going to do it your way next. I'm going to do it first with sine. Okay. Why do I choose sine? Well, I choose sine is because I got this case is the angle right here. So this becomes opposite. Does that make sense? That's opposite. And then I have hypotenuse is constant. And I like opposite over constant. Because opposite over constant is good. Now, can her way do it? Yes, we're going to talk about that because it's also because it's dy dt. But what if we evaluate dy dt wrong? Eva, does that make sense?
Yeah.
Is it possible that we make a sign mistake on dy dt? So I would rather use something that is structured in there for original question without involving with mistaking parts. Does that make sense, what I'm trying to say? I'd rather use the one that is the dx dt rather than dv dt. So dx dt is 2, and then we'll have a sine theta is equal to opposite over hypotenuse. And opposite is, in this case, is x. Hypotenuse is 25, and sine theta. Now here's the truth. The truth is to make sure, it didn't matter if I use sine and cosine, I just cannot use tangent. Yes, Robert? Oh, I cannot use tangent. The reason why I cannot use tangent because I got x and y. I don't want to deal with two variables. I want to deal with a constant that can help me. Because constant, when I take a derivative, it's going to go away. It's really nice. So now I'm going to take a derivative of this. So you'll be here. It will be cosine. It'll be d to the dt. Can anybody help me take a derivative of this? Cosine theta.
1 over 25.
There's a missing couple things here. dx dt. What else? There was something else that was missing.
Connected to cosine theta is d theta dt.
Yep, don't forget about that. That's what we want. So we want a d theta dt when x is equal to 7. That's the unknown. So you have to have d theta dt. You cannot take a derivative with no d theta dt. You have nothing to solve for. And then d theta dt is equal to 1 over 25. This is 2, right? And then 1 over cosine theta. Wait, how do I find a cosine theta?
Adjacent over hypotenuse.
Adjacent over hypotenuse, so it'll be 2 over 25. And adjacent over hypotenuse, what is adjacent in this case? Hold on. Adjacent is going to be what? What? 24, good. Over what? 25, right? So that'll be 2 over 25 times 25 over 24, right? It worked out pretty nicely. 1 over 12. It's positive. It looks good because it's increasing. Whoa, perfect. Tomorrow we're gonna talk about a shadow problem. Your homework today, you gotta make sure you can do as much questions as possible, kind of go break down each thing, and